I hope. Remember, if anything has the same base, let's say, and I'm just looking at number 1 on your classwork portion here, 3 to the 2x minus 9 equals 3 to the 7th. Anytime the base is the same, you can just set those exponents equal and solve, right? Y'all remember doing that? Okay. So 2x minus 9 equals 7, that's pretty easy. But then we moved into a little, and I'll finish this out, 16, so x is, oh my goodness. The problem comes when the bases are not the same, or you have multiple of the same bases. I guess, let's do one more where the base is the same, like number 3. If y'all don't remember this or need some extra review with it, let me know as we go. Stop me or slow down. Whenever the bases are the same. The bases won't always be the same. Okay, so number 2, the base is still the same, right? You can still drop those off and set the exponents equal. No. Why are you foiling, Carter? Okay, so Carter's jumped ahead to number 3. I don't know that I would foil that. See? That's exactly right. It's multiplying with the same base, and when you multiply with the same base, what do you do with the exponents? You add the exponents. So this would be 5. Now don't combine the base and the exponents. You only do one. 4c plus 1. Now the bases are exactly the same, and so I can drop them off and just set the exponents equal, right? Y'all okay there? I'm running through, I had not planned on spending all this time. I had planned on doing logs, exponents, and complicated logs all in one day, but just kind of review, but that's okay. We'll break it down, take it a little bit slower. But what happens if the bases are not the same? And we talked about this in Algebra 2. And there's a couple different things we can do. Say again, make them the same. We called it base manipulation in Algebra 2. Do y'all remember doing that? So, like, number 5, are you saying that, Carter, because you do, or are you serious? Do number 4? So if you add the exponents, k squared plus k plus 2k minus 9 equals 4k plus 11. I went back to 4 because they said, looks like a quadratic. How do I solve a quadratic like that? Make it equal 0 and try to factor. Move the 4k and the 11, so k squared minus k minus 20. Wait, what? Oh, yeah. What are solutions? So what if we're in the situation with number 5 where the bases are not the same? Change it to 9 squared. I think that's what y'all were saying. Y'all were saying make it a 2. And I was, what? Right? And now set the exponents equal.
What if that doesn't work, though? You know, like, what if, like...
For the case of today, we'll be able to manipulate all the bases. But if it does not work... What? No, if it doesn't, if you can't manipulate the base and you only have one exponent, you can change it to a log form. So I could make this log base 9 of 81 equals 4y minus 26. Remember them. If you can't, yeah, for today, everything you'll be able to manipulate everything today. The hardest part of these is finding that common base of what they need. Let's see, 4y minus 26 equals 2. This is still number 5. So I'm just solving it. Drop the bases off. Could I do which one? Somebody asked for one. 6? That's exactly right. I got 1 over 64 equals 4a squared minus 4. Negative what? What are you changing it to? You're changing this to a base of 4. What's the exponent going to be? Negative 3. I know that 64 is a power of 4. 4 to the third power, just because I know. So negative makes it flip. But you're going to have to remember things like, yes. You'll have to remember things like radicals, like square root is 1/2, right? So maybe some of them I have to change to an exponent of 1/2. Negatives flip it. All those things come into play big time here with our exponentials and logs. Can you solve it now? Negative 3 equals a squared minus 4. What'd you do, Carter? You added. And then you did what? You just did the thing. What thing did you just did? Did you add the 4 or you added the 3 whenever you? So you got 1 equals a squared. Or if you were here, difference of 2 squares. Either way, give you the same answer. So plus or minus 1. Look over those 1 through 16 because that'll be your classwork. And tell me what you think, which ones, because I know there's some harder ones as we go. I'll work a couple more with you. Y'all just jump straight to the last one because 15, 16, and 9. There's your 3. Do 9 first. So you better not get these wrong. 3 also, so I probably would take out my calculator and go, what is 7 to the third power, 7 to the fourth power? And it's 343. So this would be 7 to the third, but it's got this 2n minus 4 out here, and then this would be 7 to the negative 2, because 7 squared is 49, n plus 4. So now this is a little bit different because I have a power to a power, and that means I do what? Multiply, distribute. That's exactly right. So this would be 3 times 2n minus 4 equals negative 2n plus 4. Yeah. He's already out there with him. Zach got him. You can take whoever you want. How many do you need? Okay. Nice. Yes, thank you. Okay. So this becomes 6n minus 12 equals negative 2n minus 8. Easy to solve now with linear equation. Add the 2n and add the 12. Yay or nay? Yay. See. Sorry. Good. All right, 15, we get a little bit harder now. First thing I want to do is determine what base I'm going to use for these. 4. I was going to say my problem with 4 is 4 to the nothing. There's nothing I can raise 4 to get 32. I have to use 2. That's exactly right. I have to use 2. Does everybody see why? 2 to the what power is 16? 2, 4, 8, 4. But I need to make it negative since it's a fraction and it flips. So I'm going to have 2 to the negative 4. This has still got this exponent out here. 2 to the what power is 64? 6. 6. So 2 to the 6, and again, it's got this x plus 5 out here. And then 32, 5th. But it's negative because it's in the bottom of the fraction. Everybody okay there? I'm multiplying, so this is really 2 to the negative 4x minus 28. This is 6x plus 30. And this is negative 20. What shall I do with the exponents now? Add them. So I'm multiplying, that means I add. So negative 4x and 6x, 2x, and I'm just going to go ahead and drop off these bases because they're the same. And then negative 28 and 30 plus 2. What's x equal? Negative 11. This is easy, right? We could have done this and the other today, but I decided to go easy on you since it's first day back from break. Y'all are welcome. Such a nice person. You're welcome. 16. Then I'll be done. You should have time to get through both today in class before you leave. These are quick. 16. I think the hardest part about some of these is finding out the base you need to use. Did you say 8 here? 8 to the what is 512? Third? 64 is of course 2, but it's negative because it's in the bottom, and then a negative 1 here. I got 3y squared on the left. On the right, I'm going to add those together since I'm multiplying. So negative 6y plus negative 5y squared. It looks like I have a quadratic again. So I'm going to move everything to the same side, make it equal 0, and see what happens. I'll move these over on this side so everybody's positive, and I'll have 8y squared plus 6y. Now, how do I solve that? Pull out a GCF. What's the GCF I can pull out? 2y. What's left when I take out that 2y? 4y plus 3. Is it solvable now? Sure? Can I solve it now? Yes. Y equals 0. Y equals negative 3/4. If you need to show that 3/4 because you don't see it, by all means show it. That's what I did too. You added 5y squared. Did you get 0 as one of your solutions though? So you have 8y squared equals negative 6y. Anything else? Anybody else? Some of y'all are almost done with this sheet because it's super easy. I'm sorry, it's so easy. Did it insult your intelligence today? You're happy with your intelligence today? Okay.